Hello, my name is Heather Getzinger, and this is my midterm project for CIS 3367 with Professor Adrian Wheeler. So for this project, I decided to focus on flight delays. And the reason for this is that I am planning to move to Los Angeles, California next summer after I graduate from Baruch, and my boyfriend and I will need to start flying much more frequently in order to visit our families who are pretty spread out across the country. So I was interested to see which airports and carriers have the highest rate of flight delays in order to make informed decisions when booking air travel in the future. So what I did was I downloaded the raw data for my project, which you see here, from the United States Department of Transportation's Bureau of Transportation Statistics. And as you can see, this data covers the time period from August 1st to August 31st, 2016. So it's very up to date and current. And as you can also see, as I show you here, this data is very extensive. In fact, it covers 21 columns, and look at that, 1,037 rows. So obviously that's way too much data for me to try to sift through. But before I move on, I just want to point out that the only change I made to the raw data was just to adjust the column width to make all of the information easily visible, just to make it easier to read. So given this vast amount of data, as I said, I decided that the first order of business would be to create a table containing only the information that was relevant to the project at hand. So let's go over here to my worksheet, and here it is. Here's my table. And so the only information I was really interested in was the carrier name, the airport, and then these three delay types, which are the three most common causes of flight delays in the U.S., which is carrier delay, National Aviation System delay, and late aircraft delay. And the three of these combined make up between 90 and 95% of all flight delays in the U.S. So I felt that including such minimal risks as security delays would be superfluous, and I chose to focus only on those causes which I would be most likely to actually encounter in the future. So once my table was completed, I proceeded to create my first pivot chart. So let's go over here. So here's my first pivot chart. So I decided to focus on comparing the delay rates of different airports. However, to attempt to examine every single airport in the United States would obviously not be very realistic. So what I did was I placed airport here in the rows category and then added a filter. And by adding a filter, I was able to filter out only the top 10 airports that I feel I'll be most likely to actually fly in and out of based on my travel habits. So now that here are my top 10 airports, and then I also moved late aircraft delay here into values and changed the value field settings from count to sum. And the reason why I chose late aircraft delay was because aircraft are often late due to clogged pipelines at individual airports rather than any issues with the carriers, so this seemed like a natural fit. So let's go over here to my next pivot table, which examines carrier delays by airport with carriers as a filter. So at first glance, you can see it looks quite a lot like my first pivot table. Once again, here are my top 10 airports, which were created using a filter. And here, once again, well, this time I chose carrier delay, put it into values, and changed the value field setting from count to sum. However, I also added a carrier name as a filter. And the reason I did that is because carriers and carrier delays are obviously highly interrelated, and I wanted the option of being able to view the data for each airline individually if I wanted. So like here, if I wanted to view the information for Delta, there it is. And this is also reflected in my pivot chart, which is on my dashboard. But I'm going to show you that later. So for now, I'm going to go back and come on. Come on. There we go. Okay, so that's my second pivot table. And here's my third pivot table, which, as you can see again, here are the airports, the top 10 airports. And this time I chose to look at all three types of delays. And the reason I did this was because I wanted to be able to create a dynamic pivot chart in pie format for my dashboard in order to visually represent the relationships among all of the delay types and all of the airports. So without further ado, I present to you the pièce de résistance, my dynamic dashboard. So here it has 3 pivot charts and 2 slicers, and the slicers I chose were airport and carrier name, and the reason I chose those is because I obviously have no control over flight delays, but what I do have control over in the real world is which carrier I choose to fly with, and to some degree which airport I choose to fly in and out of. So I wanted to be able to manipulate those variables to reflect my choices in the real world. So as you can see, both of my bar charts here have the airports lined up on the y-axis, and the total late aircraft and carrier delays on the x-axis, complete with data labels. And then below that, down here is my pie chart, which I just mentioned, and it allows me to see the combined effects of all 3 delay types on each of my 10 airports in order to quickly assess which airports have the fewest delays overall. So what makes this dashboard dynamic is the fact that both of my slicers are connected to all 3 charts, meaning that a change made to either slicer affects all 3 pivot charts accordingly. And very quickly, let me just show you how that was done. There we go. See, look at that. All 3 are connected, and that's the case for my other slicer as well. So let me show you an example of how this works. So as you can see, before I click on anything in the slicer, here's my top 10 airports, and at a glance I can tell that San Francisco, Chicago, and Los Angeles are pretty bad offenders in terms of delays across both types here. But now let's say I'm Spirit Airlines. I want to fly Spirit Airlines. So let's go ahead and click that. And look at that, quite a dramatic difference. Now all of a sudden Dallas here, Dallas is a bad offender in terms of delays. So that's helpful for me to know. Say I can't avoid flying in or out of Dallas, but I really do not want to take the chance of those types of delays. So I made, if I go through here and choose different airlines, I'll be able to see what might be a better choice. And look at this. Here's another feature. When I click on JetBlue Airlines, look, Dallas is suddenly nowhere to be found, and the reason for that is that JetBlue doesn't fly in or out of Dallas, which is also very handy to know. And also down here, so here's my pie chart, which as you can see was also affected, and I'm just going to go back to Spirit and show you how the increase in delays in Dallas is also shown. Houston, am I saying Dallas? It's Houston. I'm sorry. If any of you are from Texas, I apologize. So here it's reflected in my pie chart as well. So to keep on with our example, let's say this type of manipulation also works with my airport slicer. However, this is much more cumbersome to use because unfortunately the slicer contains all of the airports from my raw data set, which I assume is every airport in the United States. So it's quite cumbersome to have to hold down Control, scroll through, and only choose the airports I want. However, it does still work. Here, this is Portland. So if I just want to look at the Portland airport, I can do that and see just the information. And I can do comparisons as well, but it's cumbersome and I'm not going to do it right now because it's very long and boring. Unfortunately, Clear Filter doesn't work for that. Clear Filter will work on my carrier slicer to get everything, to check them all again. But if I do that over here, it's going to check every airport in the United States, which obviously is not what I'm looking for. So that's it. This is my project, and I found this project to be extremely helpful in terms of my understanding of how pivot tables, pivot charts, and slicers can be used to distill and analyze data in pretty much any capacity. And the functionality of slicers in particular has become much more clear to me. I'm not ashamed to admit that I was pretty confused and intimidated by them before, but now seeing how powerful they are and the options they give you in terms of data manipulation. I really hope to use them going forward in both my personal and professional life. I think they're really cool and very powerful, and I look forward to learning more. So this is Heather Getzinger signing off, and I hope you enjoyed my project. Bye.